In this video, we are going to learn how to differentiate using first principles method. That is finding the derivative from the first principles. So this method helps you to understand how we have invented different rules of differentiation. Suppose we have a function that is y is equal to f of x, and this black curve is the graph of that function. And on this curve, there are 2 points A and B. If we join these 2 points A and B, and then we find the gradient of this line A and B. So now let's suppose this point B moves towards point A on the curve in this direction. So now in this curve, this red line is the tangent line. Suppose we know the gradient of this tangent line as well. Then we can observe when this point moves towards from this B point, when it reaches over here, and now we will find the gradient of this new AB line. So we will observe this gradient, the gradient of this line is closer to the gradient of the tangent line. Now it moves to over here, it reaches over here. Now if we find the gradient of this line AB, so we will observe the gradient of this line is very close to, it is getting more closer to the gradient of the tangent line. In the same way, if this point is keep on coming towards A and it is over here, and now we try to find the gradient of this line. So gradient of this line will be more closer to the gradient of the tangent line. So there will be a point. So if it is over here, so then the gradient of this line will be more closer to the gradient of this tangent line. So from this we have observed, as point B moves closer to A, this point B moves closer to A, the gradient of this chord, see this one, gets closer to the gradient of the tangent line, to the curve at A. This is the main concept which we will use to find the gradient from the first principle rule. So keep this point in your mind. When this B point getting closer to this A, the gradient of the chord AB becomes very close to the gradient of the tangent line. Now see here, this is the same curve, and let me explain you. This distance from here to here, it is x naught. So this is x naught because this distance, and this is h. From here to here it is h. Therefore, the coordinate, the point over here will be x naught plus h. So this will be the distance from here to here up till here. It will be x naught plus h. Now this is the vertical distance, and this vertical distance, because the point x is over x naught here, it will be x f of x naught. And this vertical distance up till here, because the h value is, the x coordinate is x naught plus h, so this vertical height will be f of x naught plus h. So this vertical distance is f of x naught plus h. Just putting this coordinate x naught plus h here in this x, in f of x, will give you the y value. So this is basically y value, that is vertical distance from here to here. And in the similar, this is also a y value, but this y value is from here to here, this vertical distance. Next, we are going to find the gradient of this line, this chord AB. So the formula is, but before that, we should know, if we draw a right angle triangle here, from here to here. So because we have to find the gradient, and the formula of gradient is rise over run. So this is rise, this vertical distance is called rise, and this horizontal distance is called run. So this distance, and you know that this is, what is the height of this? This is f of x naught plus h. Okay, and if we subtract this much distance from this whole one, so we will get this much distance, this the length of this line, this side of the triangle. Hence this distance, this rise, it is this whole distance from this bottom to till B, which is f of x naught plus h, and if we subtract this distance, this one, which is equal to f of x naught, so this will give us the length of this right angle triangle, minus f of x naught. Because this is this distance is f of x naught, so this is also f of x naught. So if we, this whole length till the bottom, it is f of x naught plus h, and if we subtract this gap, so this will give me this vertical length of the right angle triangle. And this gap from here to here, we are familiar, this is h. This one is h, because we already know this is h, so then this is also h. Okay, now I have drawn this right angle triangle over here, and the vertical length is written over here, and this horizontal length is written over here. So I have taken this triangle out of this diagram and redrawn over here. Now I will find the gradient of this line. It is the hypotenuse of the right angle triangle, and we know that the gradient formula, that it is y2 minus y1 over x2 minus x1. So here this y2, the upper portion is rise and the lower portion is run. So here the rise is this one, so we will put this into the numerator, and run is h, and we will put that into the denominator. So this is the gradient of this line AB. Now recall the concept which we learned in the start of the lesson, that when this B coming closer to closer A, the gradient of this chord AB will become the gradient of the tangent line. So the concept of getting closer to closer, we use for this concept, we use the word limit. We should say, in English we will say that B is coming closer to closer A. In maths we write this, that this B, when this B is coming closer to closer A, look at here. If we try to find the gradient of this big line AB, so what we will do, we'll draw a right angle triangle, and then using the rise over run concept, we will find the gradient of this line AB, and here the denominator is h. But when this point comes over here, and then we will redraw this right angle triangle again, and this is h. Now can you look at here? The h has become smaller than the previous one, and then when this h comes over here, let me change the color. So when this B comes over here, draw a right angle triangle again, and you will observe the h has become more smaller than. So when it gets closer to the A, this h will become so small that we can say that it will be very close to 0. It will not be 0, but it will be very close to 0. So we can say that this is the gradient of the line AB. But when this B comes closer to A, in maths we say that when this h becomes closer to 0. So when this h, because when this B comes closer to A, this h will become smaller and smaller. It becomes so small, it will come close to 0. So we will say that when B comes closer to A, in that which we should say, in other words, that limit when h approaches to 0. When h comes to 0, so this gradient, which was the gradient of line AB, this whole one will become the gradient of the tangent line, because we have already studied that when this B comes closer to A, the gradient of this chord AB will become approximately equal to, or very close to equal to, the gradient of the tangent line. So the word, the phrase which we are using here, that it becoming closer to closer here. So we are, in maths we say that limit when h is getting closer to 0, this whole gradient, which was the gradient of AB before, it will become the gradient of the tangent line. And the gradient, and the symbol which we use for gradient of the tangent line is f dash of x, or dy over dx. So therefore this whole expression will become the gradient of the tangent line, and we say that it is f dash of x or dy over dx. So this is the main concept of the differentiation from the first principle. So in the coming question, we will use this expression to find the derivative of any function using the first principle method. So you keep this formula or expression in your mind. Therefore, in summary, we have observed that when this B point comes closer to closer A, the gradient of line AB, which was over here, it will become the gradient of the tangent line. So the concept of getting closer to closer, we use this limit h tends to 0, and this h is basically the horizontal distance of that right angle triangle. So when the horizontal distance is getting closer to closer, it is getting smaller and smaller. So a time will come, it will become close to 0. So we will say this, that limit h tends to 0. So this gradient will become this whole gradient will become the gradient of the tangent line, and we use symbol this. Let's use this rule to see how we can find a derivative of any function using this method. Here we have a function, this one, y is equal to x squared. Normally, using the straightaway method, the derivative of this function is basically 2 of x. Okay, let's see whether we will get the same answer using the first principle method. Okay, so the formula is, so this is the formula of finding differentiation using first principle method. So see this, now the function is this one, which is x square here. Okay, so f of dash x is equal to limit, which use the short word lim for limit, h tends to 0, and it is f of this is f of x, which is x squared. So what we will do here, we will put x naught is this 4, because point is given here 4, 16, and this is x naught. Okay, so we will put here, so we will put x naught plus h, and x naught is 4, so 4 plus h. So we'll put 4 plus h into the function, and the function is x squared. So we'll put 4 plus h whole square. Okay, and then f of x naught. So we just put x naught, and x naught is here 4. So minus 4 square divided by h. Okay, now limit h tends to 0. Now we'll open this using the algebraic identity a plus b whole square. So it is 16 plus h square plus 8h minus 16 over h. This 16 will cancel out, and we will have limit h tends to 0. So it will be 8h square plus 8h over h. Let's take common from here. So now instead of writing this limit again and again, so h common. So it will be h plus 8 over h, and see this h will cancel out, and now we have limit h tends to 0, h plus 8. So this is simplified form. So we done the first part. Now we will apply this limit. What this limit is saying, h is getting closer to 0. So it becomes so close to 0, we say it is 0. So we'll put h0 here. We are applying limit here. So when we apply limit, we put h0 plus 8, so it will become 8. So the derivative f dash of x when x is 4 is 8. And look at here, the derivative was 2x, and when we put here 2 into 4, it is 8, exactly same. And look here, this first principle method is longer method, and this method where we use power rule is the very short method. But this method is derived from this first principle method. So this is the purpose of learning how these methods are invented using the first principle rule. Let's do another example. Now the question is, prove from the first principles that the derivative of x cube is 3x squared. So using the power rule, so the gradient of x cube is 3x squared, just within one line. But right now we are using the first principles. And this is the formula and expression finding the differentiation using first principle method. And we will apply this now here. And here the point is not given, which was given in the last question, but right now it is not given here. So here, so we don't know what is x naught. So we'll use x naught as it is in this question. So here the function, which is f, the function is x cube. So we'll put everything in this function. So okay, let's move. F of dash of x, it is function, we put in the function this point, x naught plus h. So what is function? X cube. So we'll put x naught plus h whole cube. Then minus fx naught. So we'll put x naught in the function, and function is x cube. So we'll put x naught whole cube divided by h. So we have used the expression formula here. Now what we'll do, we just simplify it. X cube, this one. So we can write it like this, x naught plus h times x naught plus h times x naught plus h. Because it is cube, it will multiply by 3 times, and x cube here divided by h. So now I will expand this. So you should check it yourself to save the time. So I will do it directly. Now I have expanded this x plus h whole cube. You can use cubic formula, or there is another way using binomial theorem. You may study in maths this binomial theorem as well. So using that you can do it directly. And now this minus x cube I will write over here, and whole divided by h. Okay. So now you observe this x cube, and this will be cancelled out. And okay, there is a limit here as well. Limit h tends to 0. Okay. I haven't put limit over here as well. Do put h tends to 0. Okay. And now this, and look at here, on the rest of the expression, this h is common. Let me take h common from here, and limit h tends to 0. H is common. So what left here? 3x square plus 3xh, okay, and plus h square, because we have taken one h common, and divided by h, and this h and this h will be cancelled, and then we will apply the limit that h is 0. So when we apply the limit, so we will what we left 3x squared, because there is no h, and this, when we put h 0 here, this term will become 0, and this term will also become 0. So 0 plus 0, and what we left, only 3x squared. So the derivative of the function x cube is 3x squared. Yes, you are right. So if using the power rule, you can observe this is the same derivative. But in power rule, it will take just one line, but here it has taken a lot of steps. But this method tells us how we have derived this formula. or power rule. Hope you understand this method. This is how we can use the concept of first principle in differentiation, and we also understand the concept of limit here.